Okay, everybody, we are recording. Today we are going to talk about a few different things. I'm going to wrap up our discussion on, let me think here. We talked about fiscal policy on Wednesday, or Monday, excuse me, Monday. And then we kind of talked a little bit about the branches of government, and we did a little bit of a civics introduction. And then we'll wrap that up today. And then I'll take some questions if you have any. And then we're going to talk about a very interesting topic or subtopic in economics, which is environmental economics. All right, we're going to examine how economics interacts with the environment to try to get a feeling for the interplay between the economic activity that we facilitate and the environment that we live in. All right. So first thing I want to say is we have a quiz due Sunday night, so it's going to go live after our class tonight. So we have a quiz due every Sunday, and this one, every other week we have multiple choice. So this one's going to be multiple choice. So I just want to let you guys know that will be due on Sunday evening. Okay. Anybody have any questions so far? Everybody feels caught up on everything? Okay, it should be a pretty easy class. I think the environment is a pretty easy topic to discuss when it comes to economics. Interestingly enough, a lot of people think of them as separate entities. A lot of people talk about the environment as like its own area of study, and economics as something that kind of interacts with the environment, but not really. But that's actually not true. All of our resources come from the environment. All right, natural resources that we as people use have to come from the earth some way or somehow. And remember, a lot of the interaction between economics and the environment is governed by the first law of economics, which is scarcity. There's never going to be enough of everything for everybody to have all of what they need, right? We are limited by the amount of resources that exist, but we are not really limited by the efficiency with which we can derive the usage of those resources. So economics is not a zero-sum game. A lot of people think that if somebody uses something, then that means nobody else can benefit from interacting with that person. It's like there's a pie, and the only way that I can get a bigger piece of the pie is by taking someone else's piece of the pie. But that's actually not how it works, right? If two people have something that the other person values, they can trade, and then they both get a bigger piece of the pie, so to speak. So there's an interesting interplay between economics and the environment. All right. And so I'm going to go over that today. And then, of course, if you have any questions, let me know. But before we get started with the environment, let me just wrap up our discussion on fiscal policy. Okay. Okay. Skeleton crew today, by the way, folks. And that's okay. Okay, so fiscal policy, I told you guys that fiscal policy was decided upon by the Congress, and the entities that are involved in enacting fiscal policy decisions would be the Congress, the Senate, and the President. All right, so the Congress introduces bills, the Senate passes bills, and then the President signs them into law. So the President will take a bill that's been passed by the Senate, which was originally introduced by Congress, and then the president will sign those bills into law. Individual congressional representatives can sponsor bills, or the president himself can suggest a bill and have it pushed through Congress and the Senate. So we call Congress the House of Representatives, so we always hear the House or the two houses of the legislative branch being the Congress and the Senate. So just to brush you guys up a little bit on our civics, we have three branches of government. The legislative branch covers the Senate and the Congress, and then the executive branch is has the president and then all of the executive departments that report directly to him. All right, so fiscal policy. When we talked about fiscal policy, we talked about expansionary and contractionary fiscal policy. And whenever we talk about those two things, we are referring to the economic activity that they dictate. So expansionary fiscal policy allows the economy to expand, which is things like spending, right? So the government will spend more money on infrastructure in an attempt to get that infrastructure put into place somewhere so that people can use the infrastructure in order to improve their daily lives and of course improve economic efficiency overall. And the common example that is used is something like building a bridge. All right, so if there's a bridge somewhere, then the government can say, hey, let's build this, or not a bridge, but the need for a bridge, I should say. There's no bridge yet. The government comes in and says, we need a bridge. We need a bridge because there are people on one side of the river that need to get over to the other side, and people on the other side of the river that need to get over to the other side. And so if we build a bridge, then that means that the distance between the two entities, the two sides of the river, will be cut down, and therefore they can trade. Therefore, economic activity can flourish, all thanks to the government stepping in and saving the day. All right. So when we talk about bridge building, that's something that the government has a hand in. Government builds a lot of bridges. All right. So if you are interested in civil engineering and bridge building, the government might be your future employer. So we talk about spending. We talk about decreasing taxes because if people don't have money in their pockets, they can't spend it. And if they pay their taxes, they give that money to the government, then it won't be in their pockets. So when the government decreases taxes, we call that expansionary fiscal policy. What's the opposite though? Contractionary fiscal policy. The obvious would be raising taxes. If the government wants to increase its revenue, they raise taxes. Now, absent the Laffer curve that I described to you on Monday, but if the government wants to raise some money, they'll raise taxes. And in turn, that'll take money out of people's pockets. That's the idea. And when that happens, they don't spend it. And so when people don't spend money, demand goes down and prices have to go lower in order to meet that now reduced demand. So we have contractionary fiscal policy that consists of increasing taxes and decreasing spending. Decreasing spending kind of sounds a little bit counterintuitive, but what it really means is that the government won't spend as much money on things like infrastructure, and they'll just allow people to do things as they see fit. And the idea is that there's some sort of loss of efficiency because the government isn't spending any money, which of course is not being affected by the money multiplier. When the government spends money, there is a money multiplier that you use to see how much that dollar that the government spends actually turns over and generates for the economy. But I'm here to tell you that these are a little bit misleading, right? These are the basic macroeconomic principles, and these are the basic guidelines of expansionary and contractionary fiscal policy. But it's interesting because they are tools that the Congress uses to influence the economy. But whenever they use those tools, they don't always get the intended result. All right. So let's just say the economy is heating up. And in order to avoid any inflationary traps that might result from increased economic output, the government might enact some contractionary fiscal policy, which of course is meant to slow down economic activity and reduce output. And the exchange is a reduction in unemployment over the long run. Trying to balance out that huge output means that eventually you might run into some frictional unemployment. But the trade-off is that if you increase taxes and decrease spending, you might run into a situation where unemployment doesn't do this, it just kind of does this. So that's the official literature, but I'm here to tell you that one thing does not get accounted for whenever you're talking about government spending, and that thing is the opportunity cost. So for you guys who do not remember, opportunity costs discuss everything that you could have done with your dollar that you now cannot do once you spend it. So there's always an opportunity cost. There's also an opportunity cost for when you save your dollar and do nothing with it. But for our purposes, let's just use Wendy's and Chipotle as an example. If I have $5 in my pocket and I go to Wendy's at 5 p.m. and I pay $5 for a burger, I can now never use that same $5 at that given point in time to go to Chipotle to buy a burrito or however much a burrito costs, maybe $10. But the point is that there's an opportunity cost. The opportunity cost encapsulates everything that a person has to give up in order to do something. And whenever you pay your taxes, you're giving money to the government. And of course, the government is using your money to buy whatever the government deems they think, whatever the government thinks that people should have, like, for example, bridges and whatnot. And so as a result of that, you have to factor in the opportunity cost. Okay. So if I'm building a bridge, that means that if I'm the government, I can no longer use that money to do things like build highways or hospitals. But that's not the problem. The problem is that the market no longer has that money to use for anything. Once you pay your money in taxes, the wealth that that money represents is now in the hands of the government. All right. Which is why you see a lot of things like wastage. The government gets accused a lot of wasting a lot of money and paying for things that are not necessary. Because remember, I told you guys, government agents don't have perfect information. Politicians and elected officials don't have perfect information. And so even if they think a bridge is necessary, according to the market, maybe it won't be. I don't know. I don't have a crystal ball. I can't tell the future, and I can't tell you everything about everyone in the economy. But the people in the economy can do just fine in the market. That's what we call the invisible hand of the market with Adam Smith, remember? So when we talk about government spending, you have to factor in the opportunity cost. You're going to hear in your lifetime, a lot of people are going to say, oh, yeah, we need the government to step in and spend on things like healthcare and infrastructure. But you can always remind them, hey, listen, there's an opportunity cost associated with government spending. We don't know what that money would have been used for in the hands of the private market. But we do know that the private market is pretty good at producing some miracles. Private enterprise has produced a lot of miracles in the world. It's not necessarily that we need the government to always direct and allocate resources in order for us to prosper. We just need the government to protect our property and to provide us a framework. But when the government is making spending decisions, it's not very efficient. All right. So I want to put the emphasis on market failures and government failures when we're talking about opportunity costs, but I really want to emphasize right now, uh, the government doesn't always allocate money and resources efficiently. And remember, if steel and concrete is used to build a bridge somewhere, then that's a really good example, a very clear example of something that cannot be used elsewhere. Like if I build a bridge with steel and concrete, I can no longer use it to do anything else. How's it going? Good, thank you. So just give me a second, folks. Finishing up our discussion on fiscal policy. Okay. And then we're going to talk about environmental economics. Easy stuff. Easy stuff. All right. Any questions so far, folks? All right. So we know a little bit about fiscal policy. We understand a little bit about opportunity costs associated with government spending. I don't want to beat the proverbial dead horse. And I know that you guys think that maybe I'm opposed to the government doing anything. Not entirely true. I really like how the government protects us and regulates our society with its laws and its justice system. We'll talk today about externalities, and I'll explain how crime is a bit of an externality. But today, I have an extra special lesson planned for you guys. You might even call it extra, extra special, because we're going to be talking about the environment. All right. I gave you a little bit of a preamble earlier, talking about how we as people have to interact with the environment in some capacity. All right. There's no way that we can't. This is what we got. We live in a world where we have to use resources that come from nature. All right. And those resources are scarce. They're not unlimited. And so we need to figure out a way to use them efficiently. Like I said, we have a pie, and it's not like I take a piece of pie and my piece of pie gets bigger when I take somebody else's piece of pie. No, our two pieces of pie can both get bigger if we trade and we both benefit from the trade. But those resources have to come from somewhere to begin with. I cannot give you steel or aluminum or coal if I do not first get it from the environment, because coal doesn't grow on trees. Lithium ion batteries don't grow on trees, right? For any of you guys who have ever studied the law, if you are students of the law, there is a rule in litigation. They call it the nemo quod rule. It's like nemo quod non dat habet. It's like Latin for like nobody gives what they do not have. Excuse my Latin. I like the Romans, but I don't speak their language very well. But you cannot give something to somebody if you don't have it first, right? So I'm not a legal scholar, but it's an interesting concept. It's like if you steal something from somebody, and then you sell it, you still don't have the rights to the profit, and the person who you sold it to has to give it back if they can, because you cannot give that which you do not own. So when we talk about the environment, a lot of folks talk about the environment like in very, very stark terms. Like it's extremely, extremely black and white. It's like either you can have a pristine environment and no economic activity at all, like we'll be like cavemen, like our friend from before, Mr. Ooga Booga and his brother, or you're going to have an economy that is relatively robust, but you're going to destroy your environment in doing so. There's like this association with economic activity and the destruction of the environment. Like if you want to have an iPhone, that's fine, but your economy is going to trash your environment. You're going to turn pristine, beautiful Colorado into Mordor, and there's going to be smoke and fire everywhere, and John Denver is going to be crying, and he's deceased now, so he'd be crying in his grave, I guess. But yeah, you ever heard Rocky Mountain High?
Rocky Mountain High?
Yeah, the John Denver song, like the Colorado anthem.
Huh.
Yeah, check it out. He's sad when he talks about people, more scars upon the land, as they say. But I'm here to tell you that, well, like everything else I tell you, that's not really the only answer. There is a third way, and that way is economic innovation can exist without destroying the environment. And I'll show you the trick in a little bit. But for right now, let me just ask, does anybody have any questions? None so far? Oh, yeah. Easy stuff. You didn't miss anything. All right. Before I tell you anything about the environment, however, ladies and gentlemen, I'm going to tell you a story. All right. I'm going to ask you guys to step into your time machines and transport yourselves back to the wonderful year of 2009, when I was a junior in high school. So this is ancient history for some of you. But in 2009, I started my, wait, was it 2009? Yeah, because I graduated in 2011. So it would have been 09, right? 09 to 10. Yeah, yeah. So 2000 with a single digit as the year, right? So 2009, I was in high school, and I learned a very important lesson that I'm going to explain to you guys, tell you a little story. And then I want you to just bear with me. There's nothing academic about this. I'm not going to test you on it, but just take the lesson of the story and see if you can apply it to our discussion about the environment. All right. And sit back and relax while I regale you. Okay. So like I said, let's walk back to 2009, when all kinds of societal norms were different. It was 09. What was going on in 2009? Like all kinds of different music. I think like Nickelback was still pretty famous, stuff like that. Michael Jackson was still alive for a time. I think he died in 2009. So different time. I took a chemistry class. All right. Now, if you guys have never taken chemistry, let me give you a little bit of a chemistry lesson. Pretty well known that chemical compounds have names, right? So like H2O is water, NaCl is sodium chloride, which is also just known as salt. NaO3, I think, is nitrous oxide or ammonia. So something like that. I don't know. I'm not a chemist, but you can take the little names of the elements, and when you stitch them together, you follow a list of procedures to figure out what the name of the compound is through a process known as deciding upon the nomenclature. So you got to choose the right name. All right. So like carbon dioxide means that you've got one carbon, and then di means two. So you've got two oxygen, oxide meaning oxygen. So I had this chemistry teacher whenever I was a junior in high school, and he missed school one day. I don't know what he was doing. Maybe he was sick because he didn't eat his kiwis, but I don't know. He wasn't in school. So we had a substitute teacher that passed out a paper to all of us. And the substitute said, read the paper, and it's going to ask you a question, and write your response whenever you get to the end of the paper, and then turn it in. And the teacher is going to come back tomorrow after he eats his kiwi and tell you what he thinks. I said, okay, that's easy enough. So as the story goes, I was reading my paper, and it was talking about this compound known as DHMO, which stands for dihydrogen monoxide. Okay. And so DHMO is a compound that is found in a lot of bad things, a lot of very addictive substances. It's contained in a lot of pollution and pollutants. It's pretty bad news. A lot of the issues that we find in cancer patients. We have an imbalance of DHMO, for example. And so I'm reading and it's listing all of the negative things associated with DHMO. And I got to the end of the paper, and the question that was asked was, if you were president, what would you do? Or if you were just talking to the president, how would you fix the problem of DHMO? What would you say? What policy would you enact? And so me being the young, uneducated man I was, not saying that I'm educated now, but I'm saying when I was a kid, I didn't know any better. I said, we need the government to step in and save us. DHMO is a terrible travesty, and the amount of destruction that it causes in the environment is deplorable, unacceptable, and just plain wrong. So we don't want that. So who's going to save us? Well, it's the government's job to protect the people, right? So they should come in riding on a white horse and regulate the crap out of this stuff so that we don't get harmed by it. So go ahead and put some laws in place that prevent anybody from getting DHMO. We need to stop the proliferation of this terrible, terrible substance. And so I thought, yeah, it's a pretty good idea, right? I took the high road. I wanted to save the day, right? I wanted to keep people happy and safe from this terrible thing. So the teacher came in the next day, and he had a seat at his desk, and he took out my paper, and he addressed the class because I had written the same thing as basically everybody wrote. And he said, listen, you guys have been studying nomenclature now for a few weeks, and let's just go over this. DHMO stands for dihydrogen monoxide. Two hydrogens, di meaning two, plus mono meaning one, oxide meaning oxygen. Two hydrogens, one oxygen. H2O. Dihydrogen monoxide is just water. All right. So, plot twist. The paper was written in such a way that nothing that it said was wrong, but the truth was obfuscated. All right. It was meant to elicit a reaction from me, the reader, in such a way that I was totally outraged. I was upset. I was very upset. And who wouldn't be, right? So, the point that I'm making is that whenever you hear anything about the environment, I'm telling you right now that politics and environmental science and environmental economics are really, really hard to separate. The politics is everywhere. The environmental movement these days is extremely, extremely popular. All right. There is a lot of emphasis on the environment these days. Wasn't always that way. I don't know if you knew this, but about 60 years ago, so in the 1960s, Ronald Reagan, who was president in the 1980s, was this is before he was governor of California, but he was a politician running for office and stuff. And the big issue that was talked about whenever he was running for his local office and state offices was ecology. Back in the 1960s and 70s, people didn't call the environmental issue the environment, they just called it ecology, which is the study of the environment, right? Now, if you talk to some environmental scientists, there is a bit of a difference between ecology and the environment and the science that it kind of is associated with it. But for all intents and purposes for our class, there really isn't a difference. There has been a debate going on for decades now about how we interact with the environment. It's very politicized. And so a lot of the time you'll hear stuff that's like that DHMO story, but I'm here to equip you with tools today that will allow you to separate the wheat from the chaff, as they say, or fact from fiction, easier to understand. So, cool story, huh? Saw that one coming.
Yeah.
It's easy, right? So I wish I had the paper. I don't have the paper with me, but if I had the paper, I would give it to you guys to look at, and it's really convincing. I mean,
Yeah.
the outrage is true.
The rhetoric that's used is daunting.
Yeah, like the writing, the way of writing, because it's actually pretty easy to write stuff that is written in such a way that you can elicit outrage from people. You're not lying,
Right.
You're just telling a different version of the truth, which, of course, different versions of the truth garner different reactions. It's like if I said that I was walking in the door and I didn't hold the door for the lady behind me, you might be like, "Hey, why didn't you hold the door?" But if I told a different version of the truth, it's like we were walking and there just was no door; it was just an archway. I just didn't say that. Then I'm technically not lying to you, but I'm like, I'm not really telling the right version of the truth. I'm just telling a different set of circumstances about the truth that will make you pretty upset. It'll make you pretty upset, right? That's the idea. News media does that all the time. I'm not here to bash the media. I'm not here to give you my opinions. If I do give my opinion, I say what my opinion is. But a lot of the time, you hear a bunch of different media outlets like CNN and Fox News, and like you hear Fox News is like the conservative media, and CNN and MSNBC and ABC they're the liberal media, and it's like they're both on different sides of the spectrum. But it's funny because they tell the same story. News is the same, but different people get way different reactions when they watch both sets of news. Crazy, right? So anyway, so it's hard to separate these two things, but there are ways that you can separate them. There are things that you can think about that'll allow you to make sense of what you're hearing and actually process it in a coherent way. So the first thing that I want to talk about is supply chain. Okay. Have you guys ever heard of the supply chain? Back in 2020, I would say that I would say this. If I asked you guys what a supply chain was in 2019, I bet nobody would know. I bet nobody would know if I'm just like, well, I was just a guy bebopping down the street in downtown Denver. And I said, hey, neighbor, you know what a supply chain is? They'd be like, hey, get lost, dude. I don't know. But in 2020, you can bet that if I asked somebody what a supply chain was, I probably would get an answer. Because in 2020, during the COVID pandemic, a lot of businesses were forcibly closed. The government said, hey, we don't want COVID to spread, so we're going to close the businesses that operate to make sure that people don't go out in public and spread the disease. And as a result of that, there was an enormous pressure that was exerted on what we call the supply chain, which I'll explain in a moment. But like I said, wasn't very commonly discussed before 2020. And after 2020, the big news was COVID, TikTok, and the supply chain. That was like the big three things that everybody was talking about, I guess. So the supply chain basically dictates the movement of resources from the first initial stage where they are unprocessed to the final stage to where they are finished goods. It's kind of what it covers. But I'm here to throw a little bit of a plot twist in the story, tell you that there's no such thing as a supply chain. So if you guys thought that the supply chain was a legitimate thing, I'm sorry to tell you that just like the business cycle, you've been fooled. You've been lied to. There's no such thing as an individual supply chain. And let me explain why. A chain involves a successive series of links where one follows another and it's linear. So if I start out with a glob of oil and then I process it, the oil then becomes plastic and then I turn that plastic into a ballpoint pen, right? But there are a couple problems with that story. First is that pens are not only made up of plastic, there are metal components in this pen that obviously need to come from something that's not oil. All right. The other is something that I told you in this class before is that resources have many uses. Oil is something that can be processed into like nearly 800 different products. So if you start out with a barrel of oil, there's not one destination that that barrel has. It's got like 800 possible destinations just for what it could become, as in what product it could be made into. But the potential buyers of that single barrel of oil number even in the millions. A lot of people want to buy oil, right? So instead of having a linear successive series of destinations for something like a resource, we have a web, all right? It's like you ever play that game at like arcades where you drop a ball and it's like a board and there are a bunch of pins and the ball goes like all which way and then it comes out at the bottom and that like is your score. What's it called?
Pinball? No, it's
No, pinball is like when
Okay.
you launch the pinball
Yeah.
and it like you use the paddles to flip it around, right? I'm talking about like a game where you take a ball and you drop it and it's like there's this board. It's like in your tool shop. If you have a tool shop, you know how they have those like those boards with like a bunch of holes that you hang tools on. So it's like that. There are a bunch of little pins. Yeah. And so the ball goes and you can't predict the way that it's going to go.
Right.
But when it comes out at the bottom, there's like a score for each little spot that it can come out as. And then when it comes out, that's your score. So the supply chain is actually a supply web. There are bajillions of different combinations of things that you can find, but the actual product that you have follows a successive chain. But remember, that chain is not in a vacuum. That's all I'm saying. So it's not like I mine a piece of aluminum knowing exactly where it's going to end up. I don't go to a mine in Chile and extract rare earth metals and say to myself, this is going to end up in a Tesla. I have no idea. It depends on who buys the rare earth metals. Okay. So just keep in mind, supply chain is often used to discuss supplies for a company. So like if I work in logistics, the supply chain will discuss the materials that a company uses to create its products. But ultimately, there really isn't a supply chain. And why am I saying this? Well, it goes back to the difference between micro and macroeconomics. From the microeconomic perspective, I'm only talking about things from my own point of view. And so for me, yeah, if I'm just looking at the initial starting point for all the resources that went into this pen, I'm not paying attention to all of the other possibilities that the resources could have had whenever they were being processed in order to, go somewhere else. I'm only looking at how they ended up in my hand as a pen. Okay. So that's the microeconomic perspective, but the macroeconomic perspective says there is no supply chain. It's a very complicated supply web. So when you hear congressional politicians talking about regulating things that deal with the supply chain, let me just tell you that there isn't a supply chain. Pay close attention to what they say. They probably have an interest in helping out a company that's lobbying for their cause by paying, congressional politicians, or they have lobbyists that go and present legislation to politicians and say this would be beneficial, right? Pay attention to that. All right. It's not always altruism that governs this kind of thing. So keep in mind, there's no supply chain, it's a supply web. All right. So as I said, we start out with extracting resources, right, from the environment. And we take resources from point A. They move through the supply web, they get processed, and they end up at point B as the final product. Geography plays a role in where resources go. Geography plays an important role in where resources come from because resources are not equally distributed. We'll talk about fish as a resource. We don't find fish in Kansas, but we find a lot of fish off the coast of Japan, right? We don't find gold in large quantities in Vermont, but we find gold in large quantities here in Colorado, right? So resources are not distributed equally. So when we're talking about the environment, there's got to be some interplay between what people do and how the environment is kept pristine. So I'll explain. So you've heard before people say that we need to preserve the environment. We need to go back to our roots, to go back to a time whenever we kind of, how can I say this? Whenever we didn't really destroy the environment, but we don't really destroy the environment in such a way I'll explain. But it's this concept of something called nativism or primitivism, where our friend Ooga Booga, the caveman, was extremely careful and did not destroy the environment, and therefore we should be more like him. But I'm here to tell you that the caveman suffered from something that we do not really suffer from here in the modern age, and that is known as the tragedy of the commons. Remember I told you this about like woolly mammoths, like nobody owned them, and so they went extinct, or that's one theory about why they went extinct. You don't need a theory to basically tell you how that works, though, because that's also true in basically every socialist country that you find in the world. The tragedy of the commons, folks, discusses the fact that nobody owns something, right? So if there's no private ownership of a resource, it's very poorly managed because nobody has a stake in making sure that resource stays in good condition. So another example of the tragedy of the commons that is very well documented is Iceland, right? Based on archaeological evidence and stuff like that, very, very scientific terms, stuff like that. Iceland used to be covered in trees. Okay, so there used to be a lot of trees on that icy island. And remember, I've been to Iceland. That's the same place where a sub from Subway is like $35, or at least it was in 2018. It's probably more expensive now. But Iceland used to have a lot of trees. In fact, when I was in Iceland, there was this joke, and the joke was like, How do you find your way out of a forest in Iceland if you get lost? What do you do if you get lost in a forest in Iceland? So the answer is you stand up because there are no trees in Iceland. They just have little bushes. Okay, so now we go from a point in time when Iceland was covered in trees to a point in time where there are none. Because I've been around Iceland and I can tell you that it's just covered in moss and rocks. Very pretty moss and rocks. But again, there are not really any trees unless you go out to the eastern part of the island. But why is that? Well, the truth is that the settlers of Iceland were our friends, the Vikings, from about 1,000 something years ago, maybe like 1,100 years ago. And when they arrived in Iceland, nobody really owned anything. There was no private property. They kind of just used what they could, and that was that. And so there was nobody regulating the usage of lumber. And it's also really hard to grow trees naturally in that island. And so the trees ended up being wiped out. They were cut down and used by the folks in Iceland. And as a result, what do we get? We get an island with no trees. So just like mammoths, we have a loss of a resource. So why is that a problem though? Well, let me explain. Farmers definitely have an incentive to keep their stock, right? So if I'm a farmer and I have a bunch of chickens, I know that I want to make money today, and I know that I want to make money tomorrow and a year from now and 30 years hence and 10 years after that. All right. And so you know that I'm not only going to use my chickens to sell either as meat or sell their eggs, right? I want to try my best to keep them healthy. So farmers use antibiotics sometimes, but more to the point, they put their chickens in places where they cannot be killed by other wildlife, like foxes. You ever heard of this, like fox in the hen house? So farmers protect their animals. You would never hear of an endangered animal that's also a farm animal. Farm animals aren't endangered. There's billions, millions, billions even. In fact, in a lot of countries around the world, farm animals far outnumber the population of people. Like there are more sheep in New Zealand than people, right? So they have an incentive. They own the animal. Now, let's look at other endangered animals around the world, like the tiger. Not really any people own tigers. They're hard to keep, they're hard to own, but there's no real way that you can own wild animals like that because, for the most part, it's illegal. Governments around the world say that we want to keep these animals in pristine condition, we want to leave them alone, and therefore we will not own them. Okay? But what happens? If nobody owns any resource, then people won't have any penalty for destroying that resource, right? If nobody suffers any consequences for the destruction of a resource, then what do you get? You lose the resource. In fact, many, many years ago, about a half a century ago in the United States, there were actually fewer trees than there are today. There are more trees now in the United States than there were a half a century ago. All right. The same is true in China and India. There are more trees in those countries now than there were a half a century ago. It's not a coincidence that our economies have been developing. China and India's have been developing at an extraordinary rate. They've had literally hundreds of millions of people lifted out of poverty since those days. Our country is a little bit better off, but essentially what I'm saying is that there's much more of an interest in developing trees. And so people use trees to create what? Lumber, wood products, paper, right? But a lot of people will say, we want to leave the environment alone. We want to keep the environment safe. So we should leave our resources alone. Don't touch the trees. But I'm here to tell you that we have more trees now than we did before. And we have more private ownership of trees than we did before. So if somebody says if you own something, it's going to be put at risk, how does that square with the fact that we have more trees? Does more trees necessarily mean more prosperity for all the people who want trees? I think so. I mean, it's a weird way to put it, but whenever we're talking about resources and the consumption of those resources, if there is a high demand for resources, then people will find ways to introduce those resources in a higher quantity because they want to do what? They want to rise to meet the demand. They want to increase the supply. And so, yeah, we cut down trees, but we also plant a lot of trees to replace them. Because find me a lumberjack that wants to just cut down trees because he's a maniac with a chainsaw and not replace those trees. What happens if I'm a lumberjack and I cut down all my trees? I run out of trees to cut down and I don't have any left. I run out of work. I don't have a job anymore. I'm out of a job. I got to go maybe find something else to do. And so people have an interest in the continuation of the existence of a certain resource, be that trees or animals, for example. And an interesting thing happens is when a resource dwindles in its availability, like for example, like in the 1800s, whenever the Dakotas were covered in trees, but those trees were all cut down, the price of lumber went up, right? Because the amount of supply went down. Remember our little hand trick? We had demand and supply, and then the supply was going down because we were running out of trees and people weren't managing them very well. We had the tragedy of the commons in the Dakotas in the 1800s, I think the 1880s. But the demand didn't change. But relative to the supply, the demand was pretty high. And so what we had is what? The price went up. And so fewer people could buy trees. And when fewer people were buying trees because the price was higher, they stopped cutting trees at a fast rate. The rate of cutting down trees went down. And so the management of the resource was balanced out by the market, right? Now, it would have been even better if companies had the incentive to plant their own trees that were privatized. Now, unfortunately, in those days, there was no privatization of forests in the Dakotas for a variety of reasons. But essentially, what I'm saying is that whenever you are running low on something, what you do is you find a way to get around that. You remember I told you guys a long time ago about the substitution effect, about how if you are interested in buying something but the price changes, then you have to find a way around that. Maybe if the price of rice goes up, then I would buy a cup of noodles instead. Or if the price of a TV went up, then I would maybe just buy some board games. I would substitute one thing for another. And they don't have to be totally related. They don't have to be in the same category. But there's a substitution. You buy something else with your money because you have a hole that you need to fill, but you cannot necessarily fill it with what's available. So whenever the price rises for certain resources, you have no choice but to find alternative resources that can fill that gap. It's like oil. A lot of people say that if we use up our oil, we run out of oil, we're going to be in turmoil. Not trying to make like a pun, turmoil, but we're going to have a lot of trouble, we'll say. But the problem with that is that if oil starts running out, what happens? It becomes more scarce. It becomes more difficult to find. And if it becomes more difficult to find, then what happens? The price goes up. And so the demand might not change. Yeah, sure, people with more money might be able to afford more of it, but people with more money might not necessarily be interested in buying oil. If the price goes up, like I told you with price gouging, maybe people with a lot of money might say, well, it's not really worth it. Even to them, they could buy as much as they wanted because they're very wealthy, but they choose not to because they have alternative interests. But it doesn't necessarily mean we're doomed. That means that people will try to find alternative ways to generate electricity. So that will lead me into my next topic, renewable resources. All right. So just give me a second. It's crazy how fast this class goes by. So resources are extracted from the ground somehow, right? Where rare earth metals are mined. So are you familiar with Tesla?
Yeah,
You know, their electric cars.
yeah.
So do you know
Lithium?
lithium? Yeah, it's big. A big. Yep. Yeah, lithium is a big part of producing electric cars. Do you know where lithium comes from?
It was a mountain.
Many. I mean, it comes from all over the world, but it's mined out of the ground. And so you find lithium mined out of places like China and Chile and other countries that probably start with the letter C, I would say. But lithium it's what we call a rare earth metal, copper. So copper wire is very expensive. You work in construction, right? Copper wire, you ever run across some?
Yeah, I don't use it much concrete, but yeah, I know it's expensive.
Yeah. You know what's funny is that whenever I was in the Navy, I worked at a shipyard as a policeman. And there was this guy. I was off duty one day, but I came in the next day at work, and the story that everybody was talking about was there was this guy who was riding his bike at the shipyard in July, and he had a big coat on, like a big trench coat, like a winter coat, and he was like wobbling. And so a couple of the police officers asked him, they were like, "Hey, are you okay, buddy?" And he's like, I'm okay, I guess." And they started talking to him, and eventually they found out that what he had done is he had stolen like 200 pounds of copper wire and wrapped it around himself. Like not individual strands, but he had like spools of it, and he strung it around himself, and he was riding his bike trying to leave the shipyard. So he's stealing all this copper wire because it's very valuable, right? Copper and lithium are found in batteries. And so to make an electric vehicle, you've got to mine those minerals out of the earth, those rare earth metals, and then you've got to process them and turn them into batteries and then stick them in a Tesla. So I'm going to tell you about something known as problem shifting. Okay. Problem shifting is well, it's actually something that I discussed at length whenever I was an engineering student. This is an engineering concept that is applied a lot to economics. Okay, so if you guys are ever in engineering classes, the engineering kind of concept of problem shifting is if I am constructing something and if I have an issue, I can find a way to move my problem from myself to somebody else or some other place, right? So problem shifting means I take whatever issue I'm facing and I just kick it down down the lane. So it's the same thing when we're talking about resource extraction and driving a car. So let me compare a gas-powered automobile to an electric automobile for you, and I'll show you how problem shifting actually plays out. Okay. So if I drive a gasoline-powered automobile, oil is extracted from the ground, it's refined into gasoline, and I put the gasoline into my car. It burns in an internal combustion engine. The rate of efficiency for the combustion of gasoline is, I think, very low. I think it's only like 8% of each gallon of gas actually produces any heat. I don't know, it's very low, but still, it's significantly higher than any efficiency that you find from the generation of electricity and the usage of the battery. But I'll tell you that in a minute. So my car burns gasoline and it produces exhaust. And it is that exhaust that is often billed as a problem. People say that that's pollution, and so that's it. That is a no-no. We don't want pollution, right? So what we do is we drive an electric car. An electric car has a battery. You plug in the car and it charges the battery, and you can just drive all you want, and there's no exhaust. And we all live happily ever after, right? Wrong. I'm here to tell you that we're not living happily ever after because all we have done was we've taken the exhaust that comes out of our cars and we have moved it to a different location, or we've shifted the problem, if you will. So electricity, by and large, in this country is produced by burning fossil fuels like natural gas. We all know how a power plant runs. Basically, you burn some fossil fuels, which in turn, the burning of that fuel heats up some water. The water turns to steam. The steam turns a turbine. The turbine fires a dynamo. The dynamo produces electricity. The electricity flows through the power grid, and then we use it. It powers the lights in this room. It powers the camera that I'm speaking to. It powers the cell phones that we use because we have to plug them into power sources, right? So that's how we get electricity by and large. And there are other ways that electricity is produced, like through nuclear power, which I'll touch on later. But essentially, what I'm saying is that you burn the fuel at the power plant. So what you're doing when you drive an electric vehicle is you're actually driving a vehicle that's powered by natural gas. Maybe that's not a problem. Natural gas burns cleaner than gasoline, right? It doesn't produce exhaust that's as damaging. So we know that. So we have these things called greenhouse gases. A lot of people point to greenhouse gases as being environmentally destructive, like CO2 and carbon monoxide, just CO. So carbon monoxide is just CO, mono meaning one. CO2 means there are two, oxygen, so carbon dioxide, right? Those are what we call greenhouse gases, and they are effusive. They come out of the car, right? They are the exhaust. So basically, whenever you're driving a car, you're driving something that burns natural gas. Maybe that is fine, right? But there's also the fact that you've got to build that car somehow. And for the most part, whenever you build a gas-powered automobile, you're not really using a lot of rare earth metals and minerals. You're just using steel, all right, and a few other small inputs. There is some copper wire in cars, but for the most part, steel is what you find. And it's very rare that you find any aluminum car parts, but they're there. You know, sometimes frames are built with aluminum, but you find steel frames and composite frames that make up car frames, and that's generally what you find. You find steel. Steel is made from iron. Iron is extracted and refined and purified and mixed up with carbon, and that creates very strong steel. Okay. Rare earth metals have to be mined. When they are mined, the actual process is extremely polluting. And so when people say if you drive an electric vehicle, you are actually limiting your carbon footprint, but you're not doing it right away. All right. To you, in the microeconomic sense, things are great because you're not producing pollution, right? But in the macro sense, the car has to come from somewhere. Elon Musk has not discovered how to grow Teslas on trees. He doesn't mine them on Mars, where we don't care about what happens to the environment just yet. They're being produced here on Earth. And so whenever you mine these rare earth metals, the pollution that comes out of the mines is very destructive. We don't have to care about it, truly, because it's not happening in our country. It's happening in countries where the name starts with the letter C, like Chile and China. And maybe Chad. I don't know. You ever been there? Yeah, me neither. I don't know if they have mines there. But in any case, it's polluting. Okay. So you don't necessarily limit your carbon footprint right away. In fact, it takes many years of driving an electric vehicle to actually increase the efficiency overall. Remember, I told you that we don't live in a world with supply chains. We live in a world with supply webs. And so remember, I explained to you guys economic efficiency before, where I said that you might think that you're being efficient. You might think that you're making a good decision for the economy whenever you increase the size of your bus, if you're a bus driver. You can carry more people. But what you don't think of is if you have to drive a bus that's longer, maybe you have to use more gasoline. Okay. And when that gasoline burns, not only does it cost you more because you got to pay more money to get more gasoline, you produce more exhaust for the environment. So economic efficiency doesn't just matter only to you, it matters to everybody. If you yourself think that you're doing something really wonderful and efficient for yourself, but you're increasing the overall cost that you create for the economy, the whole economy has to pay that cost, which means that it is inefficient. That's how efficiency really works. All right. That's the real trick with efficiency. Things might seem really great for you, like an electric car might seem like a perfect idea. But remember, in economics, there are no solutions, there are only trade offs. Thomas Sowell, the famous economist, he said that. You don't always have perfect answers, right? There are no good solutions. No good solutions, as in no perfect solutions. There are only trade offs. For everything that you do, you have to give up an alternative. This is the notion of scarcity again. So if I want to do something, I have to give up the alternative. I have to eliminate the alternative uses for that resource for which I can use it. So we have an opportunity cost that dictates everything that we could do that we don't do, right? But remember, we have to give up all of those opportunities in order to do what we do right now. Like the camera that I'm speaking into for the recording of this lecture for you guys, the materials that went into the creation of the lens and the electronic components and the actuator that moves the camera, you know, the servo motor, everything like that. Those things could have been used for other purposes, right? But they weren't. And so there has to be some understanding of efficiency right there. That's fine for me. Remember, value is a bit subjective in the sense that if we benefit, then it's valuable. But ultimately, we have to take into account the opposite, or not the opposite, but the alternative uses of a resource that you can find for everything that you have. Does that make sense? Okay, I'm going to get off my soapbox right now and take a drink, and then I'll tell you a little bit about some more stuff. You got any questions, Aviv?
No, I'm good.
You good, Ryan? Yeah, it's an interesting beast. You know, a couple of my students today asked me some really interesting questions. and I felt like they were questions that are worth addressing here in this class. So I'm going to ask them to myself, and then because like you don't know the questions yet, so I have to ask them to myself, and then I'm going to explain my answers. But they were opinion questions, so I just want to give you the disclaimer that these are coming from the Professor Capelli School of Economics. They are my opinion. One question that I got was about renewable resources. What's the deal with renewable resources like wind and solar? Aren't they good? And if they're so good, why don't we transition to them right away? What about nuclear power? Nuclear power is a cool alternative, right? But it's kind of scary. Some people don't use it. So, what was my opinion on these resources? And so I said this. I said that nuclear power, wind, and solar are considered better alternatives than burning fossil fuels. But let me tell you something. If we live in a society that is constrained in its use of electricity, we don't have cheap energy anymore, we don't have access to cheap fuel that can power our lifestyles in a cheap way, then what happens is we lose the ability to focus on other stuff, right? It's like if I'm in Central Africa, which is the poorest part of the world, the poorest region of the world is sub-Saharan Africa. If I'm in Central Africa, I'm not really worried about building the next computer. I'm more worried about how I'm going to feed my family, right? Because that part of the world is rather destitute. All right, it's very poor. And so here in America, we have achieved a level of technological innovation that allows us to have a relatively easy lifestyle. We have a high standard of living, which gives a lot of people in the economy a lot of opportunity to conduct research and design to find answers and solutions to the problems that we have today. We face a bunch of choices for the energy that we use, but those choices are not just random choices that people make up. We talk about things like fuel efficiency, we talk about things like peak oil production. These things are not actually in front of us. The decisions that we have to make that are actually in front of us right now are what we can do with the time that we have today. It's the same thing as if I'm a person in a really poor part of the country or a part of the world, I would say, is that I'm probably more worried about getting food and water for my family if I live in a place that's got a lot of pollution or it's hard to live in because the economy's not very good. I'm not really worried about trying to save the world, trying to save the environment, right? Because the decisions that I have to make based on what's actually in front of me are very consequential for my family's well-being, right? Because remember, we live in a society that's basically everywhere you go, not very individual oriented. We actually want to take care of our families a lot. We have a family oriented society. A lot of people will do a lot of things to sacrifice, not for themselves, but for their families. And so that's kind of how that is. So wind and solar are marketed as like this savior technology that's going to step in and make the world a better place by limiting our usage of fossil fuels. Personally, it's not actually obvious that generating greenhouse gases by the burning of fossil fuels is really all that bad. And I know that's heresy. This is my opinion, like I said, but there's not a lot of obvious research that points to the fact that when you burn and produce a bunch of carbon monoxide and carbon dioxide, the temperature goes up. In fact, in the 20th century, a lot of the rise in temperature occurred before large levels of carbon monoxide and carbon dioxide found their way into the atmosphere. Same thing with the previous century before that. So we call pre-industrial levels of carbon emissions different from post-industrial levels, but they don't line up correctly with the temperature change. I'm not an environmental scientist. I'm not here to tell you how to think about the environment. I don't really care what you think. I'm just telling you my opinion. Wind and solar are fine. One of the problems that you find with wind and solar is that a lot of people that are opposed to this environmental stuff, they don't believe in environmental science. People say whatever label you want to stick on it. They say that, well, the wind doesn't always blow and the sun doesn't always shine. And so you cannot produce electricity. That's a problem. That's partially true, right? That's kind of true, is that you can't stick windmills everywhere, right? They do damage the environment in some way, right? They kill a lot of animals, they kill a lot of birds because birds hit them whenever they spin their propellers. I'm talking about windmills. Solar panels are rather toxic, so they're hard to dispose of. And the amount of energy that goes into disposing them is very high, right? Higher than the input energy that it takes to make them, in fact. So we don't have all the answers yet. But the problem with wind and solar is not that. It's the same as you find with hydroelectricity. The problem with generating electricity using a dam is not the fact that you're doing that itself. It's the fact that you can't put the electricity anywhere. If we wanted to store electricity in the same amount that we store in oil, because oil is extremely energy dense, this is the notion that you can burn a gallon of oil and get an enormous amount of electricity from it. Oil is very energy dense. Coal is very energy dense. All fossil fuels are very energy dense. And so we cannot store electricity in the same way that we store oil, right? So we have like the strategic oil reserve or the strategic petroleum reserve or whatever. That has a lot of energy potential. In order to match that energy potential, we would have to build millions upon millions of Tesla-sized batteries. And when we do that, where do we get the minerals? Where do we get the metal? We get them from mines. And when we take that stuff out of the earth, we pollute the earth a little bit. So keep these things in mind whenever you're thinking about the environment, okay? There are economic trade-offs to everything that you do. I'm not saying that oil is the only answer. Now, one of the questions asked was, what about nuclear? This is my answer. My personal opinion is that nuclear power could solve a lot of the energy problems that we face here in the United States and in the world. But the problem is nuclear power is very scary. A lot of people don't like it because they're uneasy about nuclear meltdowns and the danger that is associated with things like radiation and cancer and stuff like that. So Japan and Germany both got rid of all their nuclear reactors. They don't have any online. It shouldn't be surprising that Japan and Germany have very expensive costs for their energy. And Japan imports a huge amount of oil to burn to create electricity. So let me just say that nuclear power, I've always been in favor of building nuclear plants. And if I were a dictator for a day, I would say, hey, we should focus on investing in these nuclear plants because we want to make new ones that are safe, like the new generation nuclear reactors are usually pretty safe, right? And there's no such thing as foolproof. But I'll tell you this, the Department of Energy maintains statistics on the amount of deaths that are associated with all kinds of energy production. So like if you work on a windmill and you die in maintaining a windmill or something, or if you work at a hydro plant, or if you die from cancer that you get from working in the production of coal or natural gas, something like that. The amount of people who have died in the last 40 years from producing nuclear power all over the world is zero. There was one guy in Fukushima, the atomic scientist that died at the plant in Japan whenever there was that bad tsunami. And he didn't die of anything associated with the reactor. He was injured in the explosion, right? So that was caused by the tsunami. So nuclear power is very safe, but a lot of people don't like it because of the stigma. The cost of building a nuclear plant upfront is pretty high, but it pays for itself many times over throughout the service life of a nuclear reactor. So I would say it's fine, but there's one even larger barrier to the building and production of nuclear reactors it's even larger than the fear associated with nuclear power. Because I'll tell you this, if you could convince the public that they would pay nothing at all for nuclear power, like if you said your electric bill year by year would be like 3 cents, I bet a lot of people would get really brave really quickly and say, okay, I'm not afraid anymore. No, the bigger barrier is the environmental lobby. A lot of people have a lot of money invested in the lobby for producing wind and solar power. And if they invested in nuclear power, all of a sudden, just like that, there'd be no need for wind and solar. And so what would happen? Be out of a job, right? And so that's the current political constraint that you find. And I'm not necessarily saying it's right or wrong. I'm just saying that's what you find. There's a very strong environmental lobby. And that very strong environmental lobby dictates a lot of the policy that affects you and me. It's like Congresswoman Alexandria Ocasio-Cortez, AOC. She's a representative from New York. She introduced the Green New Deal, which didn't pass, but the idea is it's like a, a modernized environmental version of Franklin Delano Roosevelt's New Deal, which is like a rescue plan for the economy. But this one, because it's green and green is the color associated with the environment, is meant to address environmental concerns. But I'm just telling you guys my opinion. You're never going to run out of environmental concerns. They're always going to be there. In fact, there's always like this Malthusian prediction. Malthus was the famous guy that said that we're going to run out of food and water eventually, but we don't. We haven't run out of food and water many, many times over since he suggested that many years ago. There have been all sorts of predictions going back to even ancient Greece that human beings will run out of food and water and we'll destroy our environment and we'll be doomed. And yet, here we are. We've been kicking it since the Greeks were around many, many thousands of years ago, and we're okay. And the reason for that is because of economics. We can manage the resources in our environment pretty well whenever we follow the basic rules of economics. That's what I'm telling you guys. I'm also here to tell you that there's this notion of economics that often gets overlooked because a lot of people think of economics as just the discussion of dollars and cents, and that's CENTS, but it should also be SENSE, dollars and cents. But we don't look at things like efficiency too much. I'll discuss it, but it's not something that you really look at, and I'll give you an example. If I took a water bottle, like, you get a water bottle from the vending machine, like a Dasani water bottle, and I drink it, and it says recycle me, and I put it in the recycle bin, like that one over there, and it goes into the ground, or not the ground, on a landfill. It goes to a plant and is processed and turned into another water bottle that is used to give someone else some refreshment for one time only. So the process of recycling is pretty straightforward. I take something and I reprocess it to fulfill its original use again after it's been used. The problem, though, is that for basically everything that you find these days, the cost of recycling something in energy terms is actually higher than if you put it in a landfill. Okay? There's a value to be derived from recycling. People like to recycle. It makes them feel good. It makes them feel like they're doing their part to save the environment. And it doesn't put as much of a stress on the extraction of raw materials and resources from the actual earth. But I'm going to tell you that when you look at the actual result of recycling and you measure the energy that it takes to do that, the energy cost in recycling a water bottle is higher than if you just make a water bottle initially. So that leads me to the question, Brian, do you know the difference, sir, between a commodity and trash?
Trash. It's something in use. Trash is not.
You can use trash.
Okay.
You can use it. In fact, there's a really interesting thing where people try to take garbage and turn it into like these cubes, and they're just like energy pellets, and you can burn them for fuel, and they're somehow usable. I don't know. I have a friend who's an engineer who did that for a while. He worked at a power company that did that, but I don't know how it works really. But so the difference, you're on the right track, but a commodity is something that people are willing to pay you for. So like wheat, if I have wheat and somebody wants to buy it from me, they're willing to pay it for me, it becomes a commodity. But if I have a pile of garbage and everybody says, I don't want that, it's garbage, no one's willing to pay me for it, then what do I do with it? Nothing. It's trash. No one's willing to pay me for it, right? Now, a water bottle many, many years ago would have been considered trash, right? No one was willing to pay me for an empty water bottle. However, now we would call it a commodity because there is a market for recycling these things. Even though the cost for energy might be higher than otherwise, there still is a value that people derive from recycling. If that is moral, if they say, okay, yeah, I feel good because I'm recycling something. I don't know. It depends on who you're asking. But the fact is that it's there, right? People want to recycle things. And so that's how you understand the difference between a commodity and garbage, right? If I have something and no one is willing to pay me for it, it's useless. It's garbage, right? It's not going to be used because nobody wants it. It's not going to be used efficiently because nobody has an interest in converting it into something else. So, what do you do with garbage? You throw it away. And when I say throw it away, I really mean throw it in a landfill. And remember, I told you guys that landfill is space in the country and in the world that's undervalued. Did I tell you that at all? No, I don't think I told you that. We got like 5 minutes. So landfill, you know what a landfill is, right? Yeah, it's a big empty hole in the ground. All right. People will dig up a hole, just bury garbage in it, and then they'll cover the garbage with dirt and create a little mountain. In fact, where I used to live in Virginia, there was a landfill that was called Mount Trashmore, which was a cleverly named mountain of more trash. And so what happened is basically the garbage from the surrounding area was put in this landfill and covered with dirt, and it created like a mound, right? And then it became a public park. You could just go jogging at this Mount Trashmore and run up the trash mountain. But it wasn't like you're actually running in a junkyard full of trash. It was just like a normal mountain with a hill. It was called Mount Trashmore because I don't know if you knew this about coastal Virginia, but it's extremely flat because it's all at sea level. And so Mount Trashmore was like 100 feet in vertical gain. So to us in Colorado, we're like, all right. But over in Virginia, everybody's like, wow, this is like Mount Everest. It's crazy, you know? But that's what it was. It was a landfill. Landfills are very undervalued. There are a lot of things that a lot of people do, chiefly the government, that make landfill land very cheap. It's not very valuable, all right? One of the reasons is because the government wants to encourage people to use them, right? But another reason is that like it's not a very attractive business. Buying people's trash and putting it in the ground, that's a hard one to justify. People make money doing it. That's why you pay a garbage bill. Like if you live in an apartment and there's a fee for the collection of your garbage, you pay a bill for that. You say, okay, so the garbage man comes and picks up my garbage and transports it for me. And then they in turn pay the folks at the landfill to dispose of the garbage, unless they work directly for the landfill. But you don't always find them. A lot of the time they work separately. So landfills are basically where trash ends up. All right. And a lot of trash, if you believe it, is not toxic. If you could believe me when I tell you this. Like, for example, glass. Glass is often a huge, huge target of recycling drives. So if you go and recycle stuff a lot of the time, it's glass. But I'm here to tell you, like, I'm here to tell you a lot of things about economics, is that most of the glass, I think I read one time it was like 99% of the glass that we find in our society is what we call borosilicate glass, which means that it's chemically inert. Glass is made of sand. It's just processed sand. And the sand is made of boron and silicate, which is just silicon and a couple other things. And if you leave it alone for like 1,000 years, glass just decomposes into its constituent components, which is glass making sand. So if you throw a water bottle that's made of glass, like a Snapple bottle, into the ground in 1,000 years, it's just going to be sand. But we want to recycle these things because there's an emphasis on recycling. The cost of recycling glass is higher than the cost of producing glass, but there is a value for it. So it doesn't really necessarily put a drag on the economy in terms of value, but it does put a drag on the environment, okay? Because we're burning more fossil fuels in order to do that. So before I continue, I want to say that for our next lecture, which is on Monday, because I got about 2 minutes to say this. For our next lecture, I've been dishing on the environmental lobby a lot today. I've been talking to you about how all these things that you may have heard about the environment might not be true, and I've been dishing on the government. However, even though I love to do that, and I mean I really love it, on Monday when we come back, I'm going to tell you how the government can step in and actually benefit us when it comes to interacting with the environment. The government actually, believe it or not, does do a lot of things that keep the environment pretty nice, okay? And I'll explain that third path I told you guys about how we don't have to have a stone age, like all of us are just chasing butterflies and hanging out in waterfalls, but we have no iPhones and cars. Or we don't have to have like a horrible dystopian, like super crazy polluted world where we all have iPhones and cars. There is a third way, and the government helps us achieve that way. The government helps us get to that point. So that's all I have for today, folks. I'll get to that stuff on Monday, so don't miss Monday. Remember, we always tune in at 5:30 p.m. Monday and Wednesdays in Colorado time and Mountain time. So we'll see you on Monday. Have a great weekend. And remember, you have a quiz that goes live in just a few minutes. And if you get a chance to do that quiz, it's due on Sunday night. I won't take it late, but if you need an extension, email me and I'll give you one. Don't hesitate. If you email me on Sunday night, I cannot help you. But if you email me within the next couple of days and you say, Professor, I need your help, I need an extension, and I need some guidance, that is why I'm here. I'm here to help you guys get a good grade and to teach you. So don't hesitate to email me, okay? I don't have a lot of students who email me asking for help and office hours appointments, but that's what I'm here for, all right? I don't want to give you guys zeros. I want to give you 100%. So thank you for joining me today. That's it for our class. And if you have any questions, feel free to let me know. And you guys have a wonderful weekend, okay? That's an order. Any questions, Ryan?
All good.
Yeah, that. Glass has gotta be the most useless thing to recycle. It doesn't